And now we're going to be graphing two different functions at the same time and find out where they intersect. Now, an important idea with parametric functions when they intersect, let's say this is one function, this is the other function. So as the two functions are going, it could be that they go like this. Did they intersect? So if you only look at the graph after the fact, you could say, look it, those two cars just crashed right there. But if you watch this in slow motion, here's a slow motion instant replay. So they were going like this, and it looks like they were going to crash, but the red car sped up just at the last moment so that they didn't crash. So their paths crossed, but they didn't actually intersect because they didn't get there at the same time. Thank goodness the red car sped up. So in order for them to intersect, they have to get to the same place and they have to get there at the same time. Well, t is the time. So we have to get the same t when we solve these equations. In order for them to get to the same place, that means that the x's have to equal each other. Also, the y's have to equal each other. So this gives us two equations. One is for the x's. We have 2 sine of t equals sine of 2t. And then we have to solve for t to find out what time the x's are equal to each other. Separately, we need to do that with the y values. So when does cosine of t equal 2 cosine of 2t? And if the t that we get from this does not work over here, that means that they did not get to the same place at the same time. Because if the time from this one doesn't work over here, then they didn't get there at the same time. So solve this equation. The first thing to do is replace sine of 2t with its trig identity, 2 sine of t cosine of t. Then set it equal to 0. So I'm going to take this 2 sine of t and subtract it. So it's now equal to 0. And then subtract it from both sides. So now it's going to be minus 2 sine t. And then this has 2 sine t and this has 2 sine t. So you could factor out 2 sine t. And it would leave cosine of t minus 1. Now that we've factored it, set this equal to 0 and set this equal to 0. So when does 2 sine t equal 0? Well, you could divide both sides by 2, and it really means when does sine equal 0? So it would equal 0 right here, and right here. So this would be 0 and pi and 2 pi. But 0 and 2 pi really give you the same place in space, so you don't really need both of them. So we get t equals 0, t equals pi. All right. Now, before I go into that one, I'm going to take a little break and look at the graph. So is it even possible that they intersect? That glare is intersecting my eye. So before y'all got here, I already typed it in. So there's the x's, there's the y's. Okay. And then if you look at the graph, it looks like they intersected right there, and right there, and right there, and right there. But did they get there at the same time? So let me show you a couple things that I've set up on my calculator. One is on the mode. Right here, I change it to simultaneous so that it graphs them both at the same time, and then you can see if they get to the same place at the same time. Of course, make sure it's in radians and parametric. The other thing is when I put y equals, notice that these have a circle with a little line after it. These other ones are just a straight solid line. So in order to change it to that, you go over to the left until it's highlighted, pick the color that you want, and then move the cursor down, and as you press the right arrow, it'll go through the possibilities. So this would be like when you see a baseball go through the air, you can see the ball itself, but you can't see the path behind it. This one will look like a baseball going through the air, but with the path behind it. So that's the one that I want. And now when they graph, there, they did not get to the same place at the same time. Right there, they did not get to the same place at the same time. Right there, so it looks like the two circles are not intersecting. Oh, hold on, maybe I spoke too early. Watch, watch, watch. Nope, see, just like with the red pen, that red one sped up right through there, so it looks like they don't intersect. Now let's finish the math. So over here, this would mean I could add 1 to both sides. Once I set it equal to 0, it's going to say, when does cosine equal 1? So the cosine graph looks like this. So at 2 pi, it would equal 1, and at 0, it would equal 1. And again, these two are really the same thing. So we get these three answers, which actually are just two answers, 0 and pi. Now try that over here. So if you put t equals 0, then that's going to say cosine of 0, does that equal 2 times cosine of 2 times 0? Well, cosine of 0 is 1. And this is also cosine of 0, which means this is 2 times 1. So does 1 equal 2? Nope, does not. Then check this other answer right here, pi. So what if t equals pi? Underline. So this side would say cosine of pi equals 2 cosine of 2 pi. Well, cosine of pi is right here. So that equals -1. Cosine of 2 pi is right here. That's when it's equal to 1. So does -1 equal 2? Nope. So just as I saw in the graph, it looks like they do not intersect.